Hello, good evening. We're going to try to start this over again. So, welcome. I am going to start by doing lab number 3 for Stats 243B, folks. This will be the same lab that Stats 243Z starts in a couple days, and 243A will see this lab first thing next term. So I'm going to go ahead and share my screens, and you will see that I have, I'm going to start this over again. Okay, so here I have the lab open. Share this again. Okay, now here you'll see that I have the lab open on the left here. I have a Word document where I've typed in my name and my course and my lab name, and then I have my mini tab open here. I've titled it Rule 1 and 8 rules, and now I'm going to go ahead and get started. So from here, from here, I'm going to go ahead and go calculate like it says in the lab. Random data. It says 600, roll 1, Bernoulli. That's what it says here, to select Bernoulli in the dropdown. And then enter the chances of rolling a 1 out of an 18 on a 20-sided dice. So that's 1 out of 20, which is 0.05, and hit OK. And I get a whole new row here. And then I went ahead, just because I knew that we were going to be using percentages, I went ahead and changed this part right here to percentages by going just like we did in the last lab, graph options, changing the scale down here to percent. So if you go down here and click on percent, that will change the scale to percent. So now I'm going to go ahead. I've labeled my question 1. I'm going to copy this. Try that again. Copy it over here in my Word document. I like to just do keep text only so it matches. All right. The expected percentage was 1 out of 20. So that's 5%. The observed percentage was 4.5%. And roughly, uh, roughly, we would say if we had like a really large class and everyone was doing this and everyone was plotting their percentages around, um, uh, 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 um, sorry, I need to take this real quick. Okay, so like I was saying, if everybody did this and we had a really large class and I graphed my 4.5% and someone else got 6% and someone else got 2% and someone else got whatever, like we all graphed our percentages on a little dot plot or a histogram, that would be roughly bell-shaped because we're using such a big sample size of 600. So that would be roughly bell-shaped, depending on how many of us did it, right? Like how many of our samples we took. And we would roughly expect, given it's, going to be mounded, 95% of students completing this lab should have gotten 18% range. And that's just the empirical rule. And that's what we're going to base on this one. So now we're going to hop on to this. Discuss in your report if your histogram looked like a normal curve or not, and whether or not the central limit supports your observation. So if I look over here, when I should have copied the graph and pasted it into Word, which I haven't done yet. So let's grab that, click over here, copy graph, and I can go over here, and I can put it right here. And then I can say, this is not a normal curve. And in this example, or with this data, the central limit there does not. Now, it does apply when we're talking about the class, if the whole class does it, because then we're all taking these little samples and little samples and little samples, but it doesn't apply in this particular data set role in this particular population we have looking right here. That's what we have right there. So moving on to question 2. Right now we're going to simulate more roles. So go here, and in our 8 trials, this time we're going to go to calculate random data. And we're going to go store in 8 roles. And we're not doing Bernoulli, we're doing a binomial because this is multiple trials. Number of trials, we'll do 600 again. And this time, our probability event is still going to be 0.05. I'm sorry, the number of trials is 8 trials. We got 600 rows up here. 8. We're rolling the dice 8 times, and each time the probability of success is 0.05. So we're going that way. And I am going to hit OK, and then 600 new things are going to come up here. So if you look at here, like out of 8 rolls, 0 18s, 0 18s, 2 18s, 0 18s, 0 18s, 2 18s. So let's go ahead and take a quick look at what a histogram of this would look like. And I'm going to go ahead and change this. That's fine. To row 8 rolls and then hit OK. And we have that going on right there. And so we had 0 happen 401 times out of 600. So about 2/3 of the time. We had it happen once, and then twice, and then 3 times. This is how many times 18 was rolled out of 8 rolls on a 20-sided dice. So it looks like that. I'm going to go ahead and change this again to percent because I think it'll be much easier to kind of see. If I change the scale to percent, it won't change the shape of the graph. You don't need to do this, but I am going to go ahead and do that. And there we go. I'm going to copy this graph down again. Like I said 2/3 of the time. So again, 66.8. We're going to copy that graph, move over here. And this is Q2. And I'm going to paste that graph in. Now I'm going to copy my sentence here. Yeah. All right, I'm going to shut the door so you don't hear that background noise. There we go. I'm going to make sure that this matches the destination. And then I'm going to answer. The smallest number should have been 0, theoretically. And the theoretical largest number that could have happened was 8, just to keep you, aware. The expected value for the average of the set. So this is a binomial distribution. If you remember from last term, from our binomials, the average is n times p. So our sample size was 8. We expected it 0.5 of the time, so, or 5% of the time. So 0.05 times 8. Is 0.4. So, our average, like on average, what we would have expected is 0.4. So we expect to get mostly zeros and ones, which is, what we saw. And we expected to get more zeros than ones because on average, the average was 0.4, right? The standard deviation, again, if you remember from last term, the standard deviation for a binomial is the square root of n times p times q. So q is 0.95. And so the variance is 0.38, and if we take the square root of that, our square root of this function would be 0.616. So according to the descriptive average, my data set, according to my descriptive statistics, and let's take a look at that. Right, so the smallest number to show up is going to be 0. Smallest number that could have theoretically, that's spelled wrong. There we go. Showed up in this simulation is 0. This minimum showed up. Remember I said 401 times. Our expected value. Average of it is 0.4. The standard deviation was 6.1. According to my descriptive statistics, let's hop back over here and go stats, basic stats, descriptive statistics, choose 8 roles, hit OK. What do we got? So our mean, look at that, 0.935, pretty darn close to 0.4. And our standard deviation, look at this, 0.616. We're feeling pretty impressive, aren't we? So that's pretty cool, right? So you can write that down on there, and you can observe whether or not that fell within 2 standard deviations within the mean, and it certainly did. Right, so we can talk about that. Right now, this is a choose your own adventure. So you're going to simulate more roles. You can decide how many roles you would like to simulate. So I'm going to do, just because I really like the central limit theorem, I'm going to do 35 roles, so bigger than 30. So let's take a look at what that looks like. So I'm going to do everything the same that I just did. So calculate. You don't have to do 35 roles. You can do as many roles as you want. But you are going to copy your graph in there. You're going to tell me how many roles that you put in there. So I'm going to go, all right, random data, this, instead of 8 trials, I'm going to 35. And I'm hitting OK. Again, theoretically, 0 is going to be, oh, I put it in the wrong column. Apologize. Let's try that one more time. Stats. Like nothing showed up. I left it in 8 rows. We'll go to 35 rows. All right, so here it goes. Theoretically, I could get 0 18s and 35 roles. We expect 1 out of 20, right? So 0 is going to be a lot less popular number this time, but it's still going to happen. I'm going to go graph and do my histogram of my simple histogram. Okay, 35 roles. Here we go. Hit OK. And there that is. And you notice that we're starting to get a lot more bell-shaped here, right? It's starting to go. And I could, I want to copy this. I want to tell me how many, I want to tell me, it's also on the title here. Tell me how many roles I have. And also just to kind of explore this little adventure, do some descriptive statistics. What do I see here? All right. So my mean now moves up, right? Because I have more roles, so I expect to see more 18s. my standard deviation goes down a little bit. So, because I'm getting a little tighter in what I have. All right, so now, question 4, what are the chances you observed the average was larger than 2? What are the chances that your observed average was larger than 2 standard deviations away from the expected value? If 10,000 students repeated your simulations, how many of them would have observed such a large average? Right, so if you were to repeat this, or 10,000 students did it, how many would get an average in those little tails? So how many would get an average bigger than 2 standard deviations away from the mean? So think about what our curve looks like there. We have an empirical curve. It's going to be something pretty normal. So what would that look like? What's that likelihood? What's the probability that you're in that top little tail? So think about the empirical curve, and that's how you would do this lab. I look forward to reading it. Hopefully you guys can kind of see that as my rules get bigger and bigger, like if, for example, I were to calculate, let's do 100 rolls. Right? So calculate random data. I'm going to change this to 100. Change this here, so it stores there. Hit OK. And now when I do this graph, let's see if we are looking a little bit more, even a little bit more normal. And look at that. So you kind of get to see, like, the bigger that those samples are, the bigger thing goes from something that was definitely not normal, something that was still pretty skewed at 8, to something that gets a little more normal, still a little skewed. It's still a little skewed to the right, but a little more normal, to something that looks pretty darn normal as you get bigger and bigger. So hopefully that's helpful and a good way for you to kind of understand what the central limit theorem looks like and what it is. So that's lab number 3. I am going to move on to questions for this week. So hopefully that's helpful. I got some background noise I want to clear up. Okay. So let's see what we got here. So this is from Stats 243Z. This is week 3 homework, so I'm going to move on to that. I'm going to close that window. I'm going to go back to my Canvas portal. And so for those people who are on to 43Z, looking at this week right here, homework number 4. All right. So, all right. Questions 5 and 6 on the lab. All right, so this session. Okay, so these are questions about the lab. Let me see if I have any questions about the homework problem. Okay. Okay, so this is a really important question that that is asked. I'm going to address first, and this is a question for asked by Noah. I'm having some issues with the homework problem, and he provided some pictures. But when they find the IQR, I get different answer than the homework is looking for. However, with all the equations that are currently correct in Excel using the same data set, could you figure out what I'm doing wrong or perhaps solve it in the home section tonight? So I'm going to go ahead and do that problem and I will show you what is happening here. So let's go down to that IQR problem. If this is on the right homework, I might be in the wrong section. I think I am for Noah. So this is stats 243A. Right, and here we go. Oh, sorry, that's on home 4. And I'm going to tell you what's going on. So IQR is kind of notoriously, Q1 and Q3 are notoriously calculated differently based on which software packages you use, which calculator you use. There is no universal way of calculating IQR. And if you read in your textbook, and let me pull that up real quick so you have a chance to take a look at it. So it's here. Take a quick look at this book. So as you look here, so here they give you, right, information on finding the quartiles, Q1, Q5. And if you keep reading through here, right, I also talk you how to find percentiles. So just so you know, I'm on page 103 and 104 of your textbook. I believe that they do a little explanation in here. Yeah, here it is. Note that the quartile rules used for the TI-89, the TI calculators are slightly different than in Excel and what is presented in the content. They do not use a weighted means between the values, just go halfway between the values. So and Excel does it even weights it even differently than what's being presented here in the textbook. So note the sample, this example is on a PC running Excel 2019. Older version of Excel may not have the same box plot options. They also are calculating this 5-number summary just a little bit different, which can be pretty frustrating. So let's take a look at the question that we had in My Open Math and kind of look at that particular one, which is this one right here, I believe. Question 6. And this one, question 10. All right, so we have these 10 counties, and I'm going to do it in Excel and Minitab so you can see some of the differences. So I'm going to grab Minitab, reopen it. You know, it's frustrating. It says it's frustrating that there's not a universal way of doing this. Let's go ahead and paste these. There we go. Right. So if I wanted to do stats, basic statistics, display, looking at area and which stats I want, there's interquartile range right here. There's all my things right there. Okay. Let's look over at my homework and see what I'm looking for. My median, my IQR, my mean, my standard deviation, my sample variance. So let's go over back to Minitab and see what we got. My median, do I have that checked? Yep. My IQR, my standard deviation. I'm going to assume this is sample variance. And I think that will be okay. Let's see, we go and hit okay. And there we have it. So according to this, the IQR is 2936. It's not right. Okay. Let's do it in Excel. And I'm gonna launch Excel. And again, this is because these tabs weight them differently. So I gotta find my Excel, sorry. There it is. There. Hello. It's Excel. Right window so you guys can see it. Right. Not great in terms of how it pasted on this time. Let's not do that. Okay. Repaste this. Not wanting to paste very well, is it? Try it again. Just be a lot easier to fix these things. Come on. Oh, man, sometimes it's such a hard thing to get these to paste. Right? Work. All right, let's try this one other time. I have trouble getting this to paste into Word and to Excel. Copy. Nope. Do it this way. Try that. Copying the whole columns hopefully will work. There we go. That's better. Happier now. All right, so we got our things pasted here. And now we're going to use quartile, quartile, include this one, this array. And again. Equals quartile. The one with the include. Then this array. And we want the first quartile. And I want to do the same thing with the third quartile. Include. And this array again. And we want the third quartile. And the IQR is 1.5 times, or the IQR is just Q, the interquartile range. I don't think there is an interquartile range function on this one. It's just Q3 minus Q1. Take this minus this. And this I get 255, 2,551.25. Significantly different than the inner quartile range we got here of 2,936, 2,551. So let's go ahead and put that in our MyOpenMath and see if that's what MyOpenMath is looking for. 3,551.25. And it is. So that is how you calculate the IQR for this particular problem. It does tell you that they want you to use Excel. I would like to just like show you real quick again. It's because none of these algorithms for any of the quartiles for any of the same softwares are the same. So you're going to get different answers based on which ones that you use, which I understand is problematic. The TI-89 is going to calculate the interquartile slightly different from this one as well. Because it's just going to take the average of the two numbers when it's looking for it's not going to weight them like this one is weighing the difference between the two numbers. So it's taking a weighted average between the two numbers. This one's just going to take the middle, smack in the middle. So and then the book runs through an algorithm, which I believe is what Minitab does, which is actually taking the 75th percentile of the data. So I know that this is, is frustrating. It's always kind of a problem. But the reason that I still keep this in there is you need to know that different software packages give you slightly different results when it comes to interquartile range. And that's an important thing to just understand as a researcher. None of them are necessarily wrong. The range is a rough estimate. We don't use the interquartile range for hardcore, like necessarily for hardcore inference. So it's a rough estimate and a decent one of, where the middle 50% is. So it works out fine. So hopefully that answers your question, Noah. Sorry, it's taken me a while to kind of bumble through it. So let's take a look at the next questions that I have here. So homework number 4, stats 243B, and the lab for stats 243A were questions that we had. Let's look at the lab in stats 243A first, or 243Z. So I believe that you are looking at questions on lab number 2. And so this is struggles with question 5 and 6 on the lab, and I was hoping to get some clarifications on how to get the answers. How do you find the age in the 10th percentile, and what is the 40th, the percentile of age 40 is in? Let's take a look at 4 and 5 on this lab. Okay, so this is actually not asking for the exact percentile. Let's go ahead and download it and take a look at what this particular question is asking, because it is an application of the empirical rule. So I'll go ahead and grab that data for us. Again, to download data, this way. Reopen Canvas. This is how you end up with 100 tabs open. So data downloaded in menu tab. Notice this is an MPX, which is a project, so file open, project, local file on my computer, in my downloads, and there it is. All right. All right, moving on to these examples, my lab here. All right, so question 5. Construct descriptive statistics for height and age. So we're going to do that and then click OK and put it out. So here we go. Stats, descriptive statistics, height. There those are, and then repeat the same. For age, you can actually do this too, like all together, but it says to do it and then repeat it. See, it says display descriptors, highlight height variable, click select, click OK. I'll put that into your Word and then repeat for age. So we're gonna have 2 different tables for age and height. So I would copy this graph if I just hover here, click here, copy, put in my Word document. Do it again, stats, basic statistics. We're going to do the same for age. And hit OK. And then we get these guys right here. All right. Then it asks, according to the descriptive, for heights, the range of heights are within 1 standard deviation from the mean is blank to blank, according to the according to the 68, what percent Shrine, the actual percent of heights that lie within this interval is this. So we're going to take a quick look at how to do this. I'm going to graph the heights with histogram so I can see what it looks like real quick. Go down to heights. There's my heights right here. I'm going to change this to percent. Frequency scales to percent. Just have a better look at it. Here we go. If I look at my descriptive statistics for heights, the mean is 171. So if I look at the mean is 171. My standard deviation is 9.4. So I'm just going to round to 9.5. So if I add 171, so to 180.5, and if I subtract 171, then I get 161.5. So if I are looking at this right here, if I also look at this too, oh, help us that much here. So I'm looking at this. According to the descriptive statistics report, the range of heights that are within 1 standard deviation of the mean are from just what I did. I added and subtracted one standard deviation of the mean, 161.5 and 180.5. I rounded up, you could put 0.4 if you want. According to the 95%, the 68, 95, 99 rule, the empirical rule, this would be 68% would lie in this range. What actual percent lies in that range? So what I'm asking is, right, if I do a count between 180.5, 161 down here, up here to 180.5, how many are in there? One way that we learned how that we could have it this count for us is if we go to tally individuals, cumulative counts, and 8. No, sorry, 8. We made this table last week, so we know how to make this table. And if I look down here, between 161.4, so they're in order here. We have, and I could just count these all the way up. So let's see, at 161.4, we get up to 91, right? So there are 91 below that. And we go up to 181.5. There are 435 up to 181. So if I go 435 minus 91, 344, what was my total number of observations here? 507. So 344 divided by 507 is 67.8%. So 68%. Wow, that's really awesome. So you get that? So where that actual is right here, you're gonna want to put 67.85%. Okay. The age that's in the 10th percentile is blank years old. Age 40 is in the what percentile? So let's take a look at, see if we can have Excel or Minitab calculate percentiles for us. Right, so we are going to look. There are so many different ways that we could do this, but I'm just going to use tables again. Table and put percents here. This time I'm going to put cumulative percents. Go down to age. Hit okay. And who's in the percent, the 10th percentile? Age 20. Right? We look closest to 10th percentile. Age 40 is in what percentile? The 84th percentile. Okay? This is how you make those little graphs that would show you these cumulative graphs would show you these types of things. All right, so hopefully this is helpful and you can go from there. All right, so let's take another look at my other questions that are, we had questions from 243B, homework 4, I believe. So that answers the lab 2 questions. So other questions. Homework 4, 243B. You guys can just scrub through these if you're not here yet. You can just go ahead and scrub through these questions. Oh, sorry, missed that. All right, so these questions, 3, 5, 6, 16, and 20. So in a survey of 28 people were asked how much they spent on their child's birthday gift. The results were roughly bell-shaped with a mean of $40 and a standard deviation of 5. The margin, find the margin of error at 98% confidence level. Find the margin of error at 98% confidence level. So we're just looking at the thing that you would plus or minus here. So remember, the margin of error is your t critical value. We're doing t intervals here. So I would take my t critical value here. I go distribution, inverse t, my area. I want the middle 98%. So I want the bottom 2% or the bottom 1% or the top 1%. So I'm going to go with that bottom 1%. So 0.02. Degrees of freedom here would be 27, 28 minus 1. I'm going to paste. And my t critical value is, it says negative 2.47 here. It's symmetric, so it's negative on the bottom half and positive on the top half. Those are your t critical values. To find the margin of error, you take that critical value times your standard error, which is your standard deviation, divided by the square root of your sample size. So I take this times my standard deviation, which is 5, divided by the square root of 28, which was my sample size. And this gets 2.336 as my margin of error. 2 decimal places is 2.34. All right, so that is how you would do that margin of error question. Again, this is what you would add or subtract to your mean to get your t critical value. That was question 3. Question 5 was the next one that was asked. Okay, so it says express this problem in terms of a mean plus or minus a margin of error. So this is a lower limit and this is an upper limit. The mean has to fall exactly in the middle. So 304.1 plus 418.3 divided, enter, divided by 2, enter. My mean has to fall smack in the middle of a confidence interval. Again, t distributions are symmetric, just like normal curves are symmetric. So that would give me that part right there. My margin of error is going to be the distance away from the middle to these areas. So if I take that and subtract 304.1, my margin of error is 57.1. Right, and then we go from there. Right, right, and same thing happens here. Find the average of those two, and then find the difference from the average to the endpoints to get your margin of error. And 16 and 20 were the last two questions from Leslie that we wanted to go over. So here's 16. I'm going to be lazy with 16 and put this into Excel so I don't have to type it all into my calculator. So you're a researcher, we're into Minitab, probably Excel easier. I grab Excel, which I already have open. Paste. There it is, great. And it says, what's the point estimate for the population mean length of time? So I'm going to grab this and find the point estimate is just the average. What do you mean? Do this right here. And 2.5769. 2.5769. Let's find out what the next one was. 692. So that should work there. What must be true in order to construct a confidence interval in this situation? Must be approximately normal. We have to assume that the population is approximately normal. Otherwise, it's not just gonna work out very good because our sample size is small, right? So we'll get that. All right. I don't know why it's not submitting. All right, construct a 99% confidence interval for the population mean length of time. Enter your as an open interval like this, round your bounds to 4 decimal places. So if I want to do that in this one, I believe there is a t interval function here. T int. Let's do the test. There's our array. Nope, this will only do 2 tests. We'll have to construct this interval on our own. All right, so we wanted, there's our mean. We want to find our t critical value. We want it to be 99% confident. That means we're going to use equals inverse t inverse. This is a two-tailed t inverse. Let's find out what this does real quick. Two-tailed inverse epsilon t. No, that's not what we want. Let's do just the regular inverse. All right, our probability bottom percent would be for 99 would be 0.05, top is 0.995. Do that one, that will just give us a positive one. Degrees of freedom on this are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 minus 1 is 12. And that is our critical value. And then we want our standard deviation. And we want that divided by the square root of our sample size. So our lower limit is going to equal our mean minus our critical value times our standard error. And our upper limit is going to equal our mean plus our critical value times our standard error. So we're going to go from 2.28859. So 2.28859 up to 2.8652. Make sure I rounded those right. 1, 2, 3, 4. That should be 6 then. And 1, 2, 3, 4. 2, 5 should be 3. And that should do it. All right. And what did I round right? 2.999. Did I do? Did I grab the wrong inverse? $299, 2.854. Off a little bit. Did I grab this one wrong? 99 percentile, oh, 0.005. 2 to 14, that should be good. Oh, it should be square root of 13, not 12. That's where I made a mistake. It's not divided by, it's divided by the sample size 13. And that gives us our right answers. 2.299 and 2.853. So I apologize for that. And the last question on this, Ryan, and then I'll get to your questions, Demi. Our question 20. The researcher wants to determine an interval estimate for the average height weight of gorillas in pounds. She wants to be 90% certain. So this is the minimum sample size problem, and I'm going to write out the formula for you, and then you can see where it comes from, hopefully. All right, so we know that your margin of error is equal to some t critical value or z critical value, some critical value, times your standard deviation divided by the square root of your sample size, right? We're actually, they say they want to have a certain margin of error. So they know that this is 5.7. They know they want to be 90% accurate. And so they know this right here, this z critical value is going to be your 90% critical value. So if I grab my calculator or my Excel and I go to my distributions and I go inverse normal and I have 90% in the middle, which means I have 10% on each tail, which means I have 5% on the bottom and 5% on the top. This critical value is going to be negative 1.65. So this equals net or positive. You can use the positive one. It doesn't really matter actually because you're going to square it, but 1.6448. In past studies, we know that the standard deviation for gorillas is 17.5. If we want to get this particular margin of error, what does this sample size need to be? And that's what we're asking. So we're going to solve by solving this equation, just like you would in Algebra 1. We're going to multiply this over here. We're going to divide this over here. So we're going to take 6.448, or sorry, 1.6448 times 17.5 divided by 5.7 equals the square root of n. To get rid of the square root, we're going to square this whole thing. So we're going to take our critical value. That's why it didn't matter if it was negative. You're going to square it anyway. The critical value times your standard deviation divided by the margin of error you'd like to see, whole thing squared. That gives me 25.5. So this number right here, you're going to round, you can't take a 0.5%, so you're going to round up to a whole number of 26. Okay. Oh, yeah. I want the critical value first. So this is that 1.6448. The 2 decimal places is 1.64. And then rounding up to the next integer, we want 26 here. And that's how you do question number 20. All right. Wow. I will try to do my best to kind of go through this video and let you know what time it starts, but I apologize. There's just a lot of classes this year, so it's hard to know when is what. So anyway, those are all the questions that came in via email so far. Did you want to go ahead and ask your questions, Demi?
I am generally just lost on homework number 3.
Okay, well, let's go through that then.
I'm on question 2. So,
Okay, no problem. Let me clear this annotations. All right, so you're in 340 Z, right?
yeah, 243Z.
Sorry, there's 3 different classes, so
Yeah, no.
and we're on homework 4
No, homework 3.
or 3. Okay. All right. Okay, so homework number 3 is really looking at all the different ways that you can kind of summarize data with different statistics. So the mean, the median, the mode, finding those types of different types of statistics, finding where the middle is, what the different range is, how far the data expands, how you can check it up to different percentiles. So it covers all of those types of topics. What technology are you using? What technology are you using?
Sorry. Oh, I downloaded the TI-84, the emulator that you had suggested in the syllabus or the beginning intro things, whatever.
Okay, so we can do that. Let me share a different screen. The only problem with that emulator is that you're not gonna be able to use it on the exams. Because it's tied to a phone and I can't allow phones on exams or tied to an internet device. Um, so so
Oh,
it's fine for the homework, but you might consider either borrowing a calculator. You might be able to check out a TI 89 from the library or borrowing it from someone, or not an 89, I always say 89, 84 or an 83 from the library, or um, you can use Excel or Minitab for these problems. Oh, if you would like to do those. Let's go here and let's grab this. So, um, so here I am with my calculator and my scrap paper open here on my device. So I want to find the mean. Uh, did you have any questions on problem number 1, or are you moving right to 2?
well, number 1 I thought was strange, and I don't know what I'm doing wrong. I got the mean right and the median right, and then I didn't get the standard deviation right. So never mind, that's not that strange. So,
So there are 2 standard deviations listed on your calculator. I'll do this, my set that I have here for me. Your numbers are going to be a little different. But if I go into stats and edit and get my lists up, and if I put my list in, I have 18.5, 8.4, 18.4, 13.9, 11.3, and 10.6, and 7. And then I want to clear that one out. And it doesn't want me to do that. Delete. There we go. All right, so there's my list right there. I'm going to go to stats, calculate, one variable statistic, choose list 1, leave my frequency blank and hit enter. and my mean pops up. My standard deviation for this problem is a sample standard deviation, so that's gonna be this SX. So this one right here. 1, 2, 3, 4 down. So the one that says SX, which in my case is the 4.56, right? The sigma X is the population standard deviation. If this was everything that I cared about, not a sample, but the whole population. So that is how you find the standard deviation using this the simulator. If I wanted to do this problem on Excel, which everybody has access through EOU, Microsoft Office 365 or 365. If I wanted to do this using Excel, and you can have access to Excel because it's not a mobile device. Here we go. I can paste my numbers here and I can just go equals ST and standard deviation dot S is for samples. And I'm going to highlight this and close parentheses, and that's going to be my 4.56. So those are the two ways that I could do that using technology. If I wanted to do it by hand, I would find the mean of these. So I could calculate the average, which they require you to do in the problem above. Right. But then you take every problem, every point. So I would take this 18.5 minus this average. And then I would take this 8.4 minus its average. This is how the standard deviation is calculated by hand. I would do the 18.4 minus the average. You can see why people don't do this by hand very often. I wouldn't be doing it if it wasn't a small set. This minus the average. Last three, this minus the average. This minus the average. And then this minus the average. Right. And so this gives us the distance away from the mean for each data point. Then because some of these are negative, and I can't, if I were to add them up, because some of them are negative, they would just add up to 0, which would not be helpful. So since some of them are negative, we're going to square them to make them positive. So we're going to take each number of these and square it. That makes it all positive, all the negative is positive. So we do that for that whole column. And then we are going to, so we have the mean minus the data point minus the mean squared, and then we're going to add all of those up. So this is going to be the sum of all these. Because we want to take the average distance away from the mean. And since this is a sample, we're going to divide by 1 minus the sample size. So I'm going to take that sum, we're going to divide it by 1 minus the sample size, or sample size minus 1. There is 1, 2, 3, 4, 5, 6, 7 points here. 1, 2, 3, 4, 5, 6, 7 points here. So I'm going to divide by 6 because it's a sample and not the full population. If it were the full population, I'd go ahead and divide by 7. but it's not, so. This number right here is called our variance. Okay, this is the variance. It is the squared deviations on how far each one of these things deviates squared. To get it back into the same units that we had before, because I squared everything and took the square root of that variance to get my standard deviation. And there's that 4.561222 that we had before. So that's how you would do it by hand. You would never really do it by hand. No statistician ever does calculate the standard deviation by hand, but it's really a good exercise to kind of see it once and to understand what's happening. I'm measuring the distance from the mean of every single point. And then to make it positive, so it doesn't just add to 0, I'm squaring them and then taking the average and then square rooting it to get it back in its regular units. So let's go ahead and go back to this homework assignment. So hopefully that you were able to get the right standard deviation for your number 1.
I don't, sorry, my computer is being so slow. I'm gonna try to do that, but that helps. At least I know what I'm looking for.
I'll go ahead and move on to number 2. So this would be like, if I were to write this out, this would be like, if I were to write this data set out, it would be like 3, 3, 3, 3, 3, 5 times, and then no 4s, and then 2 5s, then no 6s, and then 4 7s. See where I'm getting these numbers? And then there'd be 3 8s, and so on. But I don't want to have to write these out. I want to be able to just calculate them. So I'm gonna grab my TI-84 again. And I'm gonna type in both lists, one in the frequency into list 2 and the actual things into list 1. All right, so I've got my calculator here. Right. So I'm gonna go stats, edit, and in my list 1, I'm gonna type in 3, 4, 5, 6, 7, 8, 9, and 10. In my list 2, I'm going to type my frequencies. 5, 0, 2, 0, 4, 3, 3, 2. And now I'm going to find the mean and the median of this by choosing stats. I still just have one variable here. Because I have 2 lists, doesn't mean I have 2 variables. I have one list of variables and a list that tells me how often each of those particular variables happen. So it's still just one variable stats. It says, well, your list is in list 1. That's where your variables are. But where is your frequencies? And it says, well, before I just left that blank when I do that before, because I didn't have a list of frequencies. Now I do. So I go second, L2 for my list of frequencies, hit enter. So my mean is going to be 6.5. And if you look down here, my median is going to be 7. So I could type that into my answers. And they want to put a couple decimals in. So I'll put 6.526. And my median is 7. Enter and voila. Okay. So pretty much question number 3 on your assignment is the same, except for it asks you to find the variance. And if you look at my list here, it doesn't have variance on there. So what I need to do to find the variance is you need to take the square root that you found, the standard deviation that you found before, and square it, times it by itself, and that will get you the variance. The first time they want you to use the sample standard deviation and the sample variance. So you'll take the answer that you got for question 2 and you'll times it by itself to get the variance. The next time they want you to use the population standard deviation. And again, that's going to be the sigma x right here, which is the 5th thing down on your calculator emulator, sigma x. If I'm in Excel and I want to use the population, it's going to be stdeb.p for population. So that's how you find that. Question number 4. The mode is the number that happens the most. The mid-range is the your minimum plus your maximum divided by 2. It's kind of considered like the midpoint of your data. And the range is just the maximum minus the minimum, right? You can estimate the standard deviation by the range rule of thumb rule, which is just your range divided by 4. I believe that's correct. Range divided by 4, 23. Yeah, 23 divided by 4 is 5.75. So that's correct. All right, so it's just your range divided by 4. How are we doing? Do you have questions as we move on here?
No, we can keep going. I wish that I could get this emulator to work so I could follow along better, but I think I'm gonna, what would you suggest is easiest to use? Like if I got the actual
I would just go ahead
84%.
and get the actual TI 89. It's going to be super easy on exams. It's I said 89 again. I meant 84. The 84.
Okay.
Sorry. I would go.
Okay.
It does cost around $100. You can get them at Walmart. You can get them on Amazon. You can get them used oftentimes on Craigslist. I would get one. It's a really easy calculator to use. And as we move forward in this class, which is why, like, it's why I pushed really hard for us to have a free textbook and for you guys not to have to pay for Minitab, was so that you could afford to get a good calculator. Because when you move forward in this class and we start doing hypothesis tests and finding critical values and those types of things, this calculator is by far easiest to use. It just makes things a lot easier. And because it's handheld, you can use it on your exams and you don't have to worry about, oh, I need to switch over to Excel. I need to navigate away from my exam, switch over to Excel, navigate back to my exam. And then sometimes when you're doing all that navigation and changing windows, Smart Proctor gets anxious and shuts down. And so, so then you're in this, stressful situation where I didn't get to finish my exam because the computer thought I was cheating. So it shut me down. So I just, obviously, you can get through the class without purchasing anything and using Excel. But it's just a lot easier to use the TI. So that is my recommendation.
Okay, thank you.
So, so anyway, you are in the 243Z class, so you do have an exam this week that's opening tomorrow. For anyone watching, the exam you should have submitted your proctor form for me so that I know who to send the exam information to tonight. And your exam opens tomorrow and closes Sunday night at midnight. So, yeah, it covers chapters, homeworks 1, 2, and 3. So, it should be problems off of this type of material. We'll have the empirical rule on it, which does, again, say if you have a bell-shaped curve, you have 68% of the data between 1 standard deviation away from the mean, 95% 2, 3. We've talked about it a fair amount on all these videos because it's in every class. It's, kind of the part of the backbone of statistics. It will have a lot of graphs on it, like reading this particular stem plot would be an example of a question that might be on there.
That was one question that the lab, and I am sorry, I do apologize. I think this feels like it's reading a different language. It's so hard. But the lab had a stem and leaf plot on it. Is that what you just called that? And it
Yep.
had 3 rows
So,
whenever I did it in Minitab.
yeah, I get that. Let me show you a picture. Let me switch share screens for a second and I'll show you what's going on there. All right. So this is probably kind of the stem and leaf plot that is most standard and makes the most sense. Why is it not sharing? New share right here. Share. Okay, it's sharing. All right, so this is the stem and leaf plot that probably makes the most sense right here, that most people are used to, right? If I were to do a stem and leaf plot in Minitab, let's say I'm going to do a stem and leaf plot for the group age here. So I go graph, I go down to stem and leaf plot. Of course it has. Sorry, my Minitab expired, so it's going to shut down on me. Let's try it again. Okay. All right, so if I'm going to do my stem and leaf plot, stem and leaf, I'm going to do it for age. I'll do increments of 10. It's the most common. There we go. All right, so you're like, okay, this is an 18-year-old. 18. There's a whole bunch of 18-year-olds, there's a bunch of 19-year-olds, and then there's a whole bunch of 20, 21-year-olds, so on. These pluses mean that there are more than is being shown here, right? These numbers over here, this third column to the left, that is not normal in a stem and leaf plot. What that is giving you is a cumulative count. So there's 26 in the first row. There's 271 up to that point right there. And the median is in that point. And then it's counting down from here, from the median. So there's 210, and then there's 92 to the end, and then there's 23 to the end, and then there's 7 to the end. So this is giving you this like weird cumulative count up to the median and then down to the end. How many data points are up to the median? And when you get the median, how many data points go down to the end? So you notice this says 7 here. That's because there's 1, 2, 3, 4, 5, 6, 7 people who are in this data range. This says 23 because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 people here plus 7 people here makes 23 until the end of the data set. So at this group, there are 23 until the end of the data set. There are 92 to the end of the data set here, and so on. This has parentheses around it because it's saying the median is in this area right here. So if I were to find where the median was by using my descriptive statistics for age, I'll see that the median is in the 20s. It's 27. Right, so that gives you an idea of what that parenthesis says. Hey, your median's in this group. Doesn't tell you where the median, what the median is, but does tell you what group it's in. So that's what Minitab is doing here. Not all programs give you a third column here. A lot of programs just do the two columns, the stem and the leaf. So that third column is a running total. So,
Okay, that makes a lot more sense.
all right. Are there any other questions that I can answer for you?
If you don't have any other questions before you go, could you just show me the quartile one really quick, or find
Sure.
this in the third quartile?
Yeah. Is it so? Which one are we looking? Let's see. Let's find. Let's do this one right here. All right. I'm going to use my TI 89 or my TI for this. Right here. So I'm doing number 25 from your homework. So I'm going to take in, I'm going to go to stats, edit, and in list one, I'm going to put 4, 5, 6, 7, 8, 9, and 10. And in list two, I'm going to put the frequencies 6, 11, 7, 11, 9, 12, 7. They have to match up. They have to have the same number of things in each list. And then I'm going to hit stats, go to calculate, choose one variable statistics. My list is in list one and my frequencies are in list two. So it should look like this on my calculator. I hit calculate, and up is going to come a whole list of statistics for me. The average number of pairs of shoes is the mean is 7.1111. The median, if I scroll down here, the median is 7. The first quartile, which is the 25th percentile, is 5. And that just says Q1 right there, 5. The third quartile is Q3, and that says 9. What percentage of respondents have at least 7 pairs of shoes? 50% or more, because 7 is the median. 0% of all respondents have fewer than how many shoes? Fewer than 4. Everybody has more, 4 or more. So fewer than 4. So that is what that is looking for. All right. Sometimes different programs will calculate the quartiles differently, and I talked about that earlier in this video. On a test question, I will know what all the different softwares put out for quartiles, so you will get credit for whichever software you are putting out for that. So so kind of go from there. All right. Hope that one was helpful.
Yes, thank you. You make it look really easy. I don't know why I have such a hard time with it. I think I need the, I guess, actual calculator in front of me.
I think
Hopefully that will make it easier.
I think it really help. I really do recommend it. And right now it feels like, oh, I don't really need it, maybe. But when we get further on, this thing it's just a couple clicks and you got an answer that you can interpret. Where I just doing Excel makes it quite a bit more difficult, so. So I do recommend, getting the calculator. And then, if you only need this term and you never use a calculator again, you can just sell it to a future stats student and just, throw it on Craigslist or eBay and somebody will buy it from you. And you
Yes.
can recoup some of your money. So, or you can give it to your kids to use in their math classes. If people
Oh,
have
it's awful because I had one.
kids.
And then I was like, I'm never going to take another math class again. So I will get another one. But yeah, I think it's going to make it easier. And I thought that our test wasn't until next week. So I will work on this. I'm going to get that right away. And then hopefully that helps me get it. Because you make it look really easy. And I feel like that's what I'm doing. But I was not finding the right answer. So I'm going to hopefully, yeah,
Yeah,
calculator's the answer.
yeah. So, well, awesome. I hope that works out. And if you have any questions, please go ahead and give me drop me an email or whatever type of communication works best for you. But yeah, feel free to let me go. I'm going to stop recording here.